हेलो फ्रेंड, हाउ आर यू? कैसे हैं आप लोग? In this video I'm going to talk about the second part of GCNN. In the first video we have talked about the theoretical part of graph convolution neural network, how it is the work, how it is work for graph classification and as a supervised learning. In this video we will see a coding perspective of GCNN. In this video I have implemented the GCNN in Python language and in the on the Kaggle platform. If you don't know about Kaggle, please let me know in the comment section below, and I will produce a separate video for the Kaggle, how you can use Kaggle and how beneficial for the data scientists and all. So if you have not seen my first video regarding GCNN, please, I highly recommend go and watch that video, and let's come on the coding part of GCNN. So in this video I'm going to implement GCNN model. So first of all we need to install some libraries, and to install and import some libraries you need to I recommend in this library Stealer graph. To implement the graph in your coding, to store your graph in a variable, you need this library. So if you not have this library, install it, and after that installing this you can simply jump on importing the libraries and all this part. Here we are importing the libraries we are going to use in this. There are lots of pandas, NumPy and TensorFlow. So all these library you are going to use in this. So let's come on the very first task of the coding. Import the data. In which data we are going to implement this GCNN? So there is a dataset called protein dataset. If you want to know more about what kind of dataset it is, so I will give the link in the last, and you can go simply on check on what kind of dataset it is. So in simply it is a kind of protein architecture, like it is a kind of graph with some molecules and edges. uh, if you see the description of this graph, you will find that there are 1113 graphs in this, and on an average every graph have 39 nodes and 73 edges. So what every node present? Every present, as I told you in the GCNN, every node have some features, and those are connected with some edges can also have some features. Okay, so in this model we are not talk about the what happen when edges also have some features. Okay, in this model we only talk about the feature about the nodes. So in this dataset our dataset have four attributes, four features. It can be anything which can represent the protein nodes or any kind of molecules. I don't know much about chemistry, so it is hard for me to explain what kind of dataset is it. So if you want to want more, so just go on the link I will give in the end of the video. So what we are going to do in this, every graph present it is enzymes or non-enzymes. So we are going to fit a classification model. So we can see the graph, actually model see the graph and tell is it kind of enzymes or not enzymes. So let's start. So the second task after importing dataset in a variable, the second type is let's explore the dataset. Okay, so let me print the very first graph of the dataset. This is a zeroth graph, or whatever you can say, on the zeroth index what kind of graph has been stored. So there are number of nodes in this is 42, and the number of edges in this is 162. Okay, so what a nodes represent, there is a float type vector with a length of 4. Okay, and what edges present, it is kind of default architectures, and you can say there are 162 edges, and the feature is none. Okay, so let's come on to the second. What is stored on the one-third locations, one-third index? In the second graph, you can see there are 27 nodes with 92 edges, and these 27 nodes represent a float type vector with a length of 4, and edges are with none features, and also there is a weights of 1. Okay, every edges have weight of 1 though, so there is no sense to talk about the weight. Okay, now next there is a summary of our data sets. There is this information about the classification. There are two class, 1 and 2. 1 represent the enzymes and 2 represent the non-enzymes architectures. So there is a 163 in enzymes and 450 in non-enzymes, you can say. So I store the labels in this variable. Let's prepare some graph. Let's say it is a kind of generator. So in the previous video there, as I had told you, GCNN means stand for three things: G for graph, C for convolutional, and NN means neural network. So as you can see in the image, we have in the green color rectangle we have the graph, and we in the last we need some kind of class. How we are going to do this, I mean how this classification work? In the previous video we have talked this kind of architecture in detail, so there is no need to explain again. In short, we can say there is three things: G, C, and NN. G means you need to solve the graph. How message passing thing is going to done, you can see in my previous video. And in the second part we talk about the convolutional, how convolutional work. There is a pooling, there is a convolutional thing, so how it is going to work. And after this we will talk about the NN, which is nothing but a fully connected neural network, a layer kind of things. So let's come up the first G, how G work. So here is the coding for G. You need to prepare some kind of libraries and functions, activation functions. You need to mention how you are going to implement this message passing thing is going to happen. And in the last, in the second, you need to work on convolutional. So here we have implemented a convolutional model, and we all know the what will be the output of convolutional model. There is a 2D array, which can be an image or something similar to an image. And after this, when we have a 2D array, we need to do one convert it in 1D array, and that is why in the neural network part, we first of all we have flattened the array. What is the output of this convolutional part? Okay, this output of this convolutional part go in the neural network part, and when it is go, first of all we flatten the 2D array and make a 1D array. And after on this 1D array we implement the fully connected neural network by giving the activation function ReLU, and there is a number of nodes in this layer is 128. There is only one layer of hidden layer, and there is a dropout on this 0.5%. And in the last, let's come on the output layer. Here there is a output layer, and in the output layer, as we know, there is a two classification. Either it can be enzymes or non-enzymes. So I have used the sigmoid activation for this, and whatever the output of this layer, it's going to be our prediction. Okay, now let's create a object of model, which is as a model, and later let's train the model. So here we split the training and testing is train I have given 0.9, which is means that 90% of the data is going for the training and other 10% is going for the testing. So here is the separation of the dataset in the training and testing part. Epochs, I have used only 25 epochs. As we know, it is not enough, but I don't have much time to train the model as 1,000 or 100 epochs. So that is why to get quickly a result, I have implemented with 25 epochs only. And let's train the model. We have trained the model and print the history of this is really insane. It is not looking like we are getting a good accuracy or something. It is because we have implemented this model with only 25 epochs. So if you are enhance the epochs, it will seriously work, and you will get the good accuracy. So here we test on testing data, and we get a loss of 0.61 and accuracy of 66.96%. Okay, here is the references. I highly recommend to get more information about the implementation part. It is a quickly demonstration. I will give the link of this demonstration in the description, but I highly recommend, if you want to know more about the implementation part, you need to go through with these three things, these blocks and these two papers. And if you want to learn more about dataset, you can follow these two links. There is a blog regarding this where this dataset has been used in many paper, and the second is this the actual paper of the dataset. Okay, and in the last but not least, like, share and subscribe my channel. Bye.